everybody. I'm going to attempt to make this video directly after a long day of teaching you all, so hopefully that goes well. I want to thank you all for a good first week. I think we're off to a really strong start. The idea of this transformations quiz is to really see where we are with transformations. I was explaining to the 7th period that the thing about honors is I think we typically think that honors goes faster and a faster pace, but I think honors sometimes means that we slow it down until we make sure that we really conceptually understand it. So that's why I'm more comfortable taking some time on these transformations, because I want to make sure that we actually understand it well enough to do some harder problems, which some of these are a little bit harder. Okay, so let's start off with number 1, f of x. Got our function up here. F of x. Oh, sorry, one sec. Draw. There we go. F of x equals 1 over 2x and then minus 2. Okay. So what we should notice is this is the parent function for this is 1 over x, which is a hyperbola. So with hyperbolas, I think the best thing to do is to identify the asymptotes, which means that we should look for any shifts occurring. All right? So we notice that this minus 2 right there, that is affecting output, okay? It's affecting the outputs that we get. So that means whatever output we get by doing 1 over 2x, we're going to subtract 2 from that, which means that the whole graph is going to be shifted down 2. All right, so we can just come in here and draw a nice little asymptote at -2. Okay, so there's our asymptote. And our vertical asymptote, since it has not been shifted left or right, is still going to be the y-axis. Okay, so we have our asymptotes intersecting down there at 0, -2. All right, so the next thing we should do is we should think about what points are going to be on here. Okay, and I think the best way to do that is to make an xy table for 1 over x, so then we can think about what's going to happen when we do 1 over 2x. Okay, so 1 over x. That's what this table is for. All right, so normally with 1 over x, we'll go ahead and we'll plug in 1 and -1. And we notice that if we plug in 1 for x, we get 1 over 1, which is just 1. And then if we plug in -1 for x, then we get 1 over -1, which just gives us -1. All right? So normally, on our parent function for a hyperbola, what we would do is we'd go to the intersection point of our hyperbola, which is in this case is down here, and we'd go over 1, up 1, over 1, down 1. All right? But that's for the parent function. Our function is different because it's 1 over 2x. Okay? So we're going to talk about what that means. But right now, it's best to just lay out all of the normal points. All right, so the next thing we would do is we plug in 2 and -2. All right, so if we plug in 2, we get 1 over 2, which is just 1/2, which we can write as 0.5. And if we plug in -2, then we'll be at -0.5. So we're at 0.5, and we're at -0.5. All right, okay, so once again, normally on our graph, what we would do is we'd go over 1 and we'd go over 2 and up 1/2, and we'd go over 2 and down 1/2, and those would be on our graph. But again, we have to make sure we apply our transformations first. Okay, so last thing we would do, we probably would plug in like 0.5 and -0.5. We may need to review how we divide by a decimal or divide by a fraction, like 1 divided by 1/2. But for now, let's just notice that we have 1 divided by 0.5 when x equals 0.5, which will give us 2. Plug it into a calculator if you don't believe me, and then -0.5 will be -2. All right? But we are applying a transformation, right, of 1. It's 1 over 2x, okay? So what's happening in this transformation is we are multiplying by a factor. And what some people said today is that we were multiplying by a factor of 2, which doesn't seem quite right. I mean, x definitely is being multiplied by 2, but the whole function, the whole output, is being multiplied by 1/2. We're multiplying by 1/2. All right, 1/2. okay? Because, we'll just go up here, 1 over x times 1/2 does give us 1 over 2x. And again, maybe we need to review what it means to multiply by fractions, okay? But that means we're multiplying our outputs by 1/2, all right? So our xy table now, our inputs are going to be the same. We're still going to be plugging in 1, -1, 2, -2, and 0.5 and -0.5. But now our outputs are being multiplied by 1/2, which is another a way of saying that we're dividing them by 2. So now at x equals 1, instead of having 1, we're going to have half of 1, which is 0.5. Instead of having -1, when we plug in -1, we are going to have half of that, which is -0.5. Half of 0.5 is 0.25. Half of -0.5 is -0.25. And then half of 2 is 1. Half of -2 is -1. Okay, so these are what happen when we multiply. These are the points we get when we multiply our outputs by 1/2. Right? So this tells us where we are going from our intersection point of our asymptotes. Okay? So the first thing we're going to do is from our intersection point, we're going to go over 1, and we're going to go up 0.5. Okay? So that's what we'll do. We'll go over 1, and we'll go up 0.5. There we are. Okay? Could probably do a little bit better of a job of writing that. Nope, still no. Getting used to writing with this pen. So that's something that you'll see me improve at as the year goes on. Okay, we'll just call that good. So we're at the point, we went over 1, up 0.5, and then now we're going to go over 1 and down 0.5. Okay? And then now we're going to go over 2, up 0.25. Okay? So we'll go over 2, up 0.25, so not quite up as high. Okay, come on now. All right, so eventually we can get this point on here. Hopefully it's easier for you. There we go, that's probably good. All right, so we went over 2, up 0.25. So now we're going to go over 2, down 0.25. Always a little bit to the left, huh? There we go. All right, not quite far enough down, though. Okay, there we go. So we went over 2, down 0.25, and then the last thing we got to do is we got to go over 1/2 now, and up 1, and over 1/2 and down 1. Okay, so we'll go over 1/2, and we'll go up 1. So that'll put us about right there. Not quite about right there. And then we'll go over 1, or over 1/2 and down 1. That gives us our next point. And now we can just connect our dots, which I am going to really do a good job of here. That wasn't as bad as I thought it'd be, okay? And then same thing down here. Okay, so hopefully you do a little bit better job of drawing as long as you use the points in the table that we just did. You should be able to do that one just fine, okay? So there is our graph of 1 over 2x minus 2, and we're done with that. All right. Okay, so next thing we are going to do is we are going to graph f of x equals, okay, 4 times the cube root of x minus 2 squared plus 2. Okay. So the best thing to do here is just really to remember what our parent function looks like. Remember, we kind of call this the bird function because it kind of looks like a bird flapping its wings. So with these guys, definitely always find the vertex first, okay? With these functions, always find the vertex first. So we notice that there's definitely some shifts going on here. One of those shifts is affecting our inputs, our x values. So the ones affecting our x value is right there. Okay, so our inputs are being affected by that -2. As we know, that means we're shifting to the right 2. And then once everything is said and done, our outputs are being affected by this +2. So our outputs are having 2 added to them, so we're moving up. So that means that we are going to move to the right 2, and we're going to move up 2, and that is where our vertex is. So we'll go over 2, up 2, boom, there's our vertex. Okay. Next thing we need to do is we need to notice that our outputs are then being multiplied by 4. Okay. Our outputs are being multiplied by 4. So that means that instead of going over 1, up 1, like we normally do with this function, because the cube root of 1 is, or the square, 1 squared is 1, and the cube root of 1 is 1, so we'd go over 1, up 1. Instead, we are going to go over 1, up 1, 2, 3, 4, over 1, up 1, 2, 3, 4. That puts us up here at the point 3, 6. We're also going to have a point at the point 1, 6. Okay. Now to sketch this, we just need to remember the general shape of our parent function, and we know that again it kind of looks like this bird situation. Okay. I would recommend graphing these on Desmos as well, or maybe even on a graphing calculator, so you can see, get a better idea what the shape is instead of just trying to like draw them perfectly. You can put them on Desmos when it's all done, right, to make sure that it looks about right. Okay, so then that's it. We're done with that one. That is 4 times the cube root of x minus 2 squared plus 2. All right. Definitely just always go back to the parent function. Remember to find the vertex 2, and then apply any reflections and dilations that happen after that. Okay. This next one definitely tripped people up. First of all, what we should recognize is that when we raise something to the 1/3, that is just our cube root function. Okay, so raising something to the 1/3 is the same thing as taking the cube root. Now, what really, I think, tripped people up about this one is that we have 2 minus x. 2 minus x. So it gets tricky because, again, we want to find our vertex first all the time. And we know our rules for horizontal translations, what we do. But we need to think about why those rules are true. Okay, so actually, if we even just go back to our other one for a second, we knew that our vertex was at the point 2, 2, because when the transformation's happening on the inside of whatever the parentheses or the square root sign, whatever, we do the opposite of what we would think. So since it's minus 2, we go to the right 2. But that's because we want to make it 0, right? We want to make the inside 0. So if we plug in x equals 2, that's what's going to make it 0. That's why we went to the right 2. So if we go back to this problem, we have to think about what are we going to plug in for x that's going to make the inside 0. So if we plug in 2, which a lot of people wanted to do, let's try it. If we plug in 2, well, we get 2, or sorry, if we plug in negative 2, which is what a lot of people wanted to do, if we plug in negative 2, we get 2 minus negative 2, which gives us a positive 4. When we subtract a negative, we actually add, and that's not 0. That's not what we want. Okay, so let's go back. What we want to plug in instead is what I said earlier. We want to plug in 2, because when we plug in 2, we get 2 minus 2, which gives us 0. Okay, so this shifts to the right. It shifts to the right. Okay, and then it shifts down 3 still. Down 3, because that is happening to our outputs. So our vertex is actually at the point 2, negative 3. 2, negative 3. There it is. All right. So now we need to think about any other shifts that might be occurring, because if there are no more shifts, we can just draw our parent function at our new vertex and we'd be done. But unfortunately, I think that there's a little bit more work to be done. Okay, so let's examine this 2 minus x part again. Okay, so what we have is we have 2 minus x to the 1/3. Okay, well, with addition and subtraction, the good thing is it doesn't matter what order we do it in. So what we can do is we can move this x up front, because that's where we usually like it. Okay, but now there's a problem, because remember, we always look at this and we say, well, if it's plus 2, we do the opposite of what we think, so that means we'd shift it to the left. But that's not what this is saying, right? Well, it is saying that if we remember that it's negative x out in front. So what we should do is we should think about what is this